How's it going, everybody? In this video, we're going to take a look at GRE over IPsec. Now, you may be familiar with this from your normal production environments and things like that. And the general idea with GRE over IPsec, what that enables you to do is it enables you to form dynamic neighbors over a IPsec VPN tunnel. So you can run EIGRP on both ends of your tunnel, and you can form dynamic neighbors over it. And an advancement to this is what DMVPN does. So we're going to get into DMVPN here real soon, but I want to make sure everybody understands the migration path if you want to go from GRE over IPsec to DMVPN. So why would you use GRE and IPsec together? So the general idea here is crypto maps have no interfaces in the in the routing table. So that's going to be the first thing that's going to be something that you're going to want to pay attention to. So typically when you're doing static routing, depending on the size of your environment, I've worked on some small ones that static routing does the job. You don't need an advanced to advance or complicate your routing by having a dynamic routing protocol involved. And the most common reason I hear is, well, with a static route I can control on a per host basis. And I'm like, yes you can. But the thing with dynamic routing, typically you can manipulate how traffic flows by doing a policy route or some other capability. And if you need to, you can modify how traffic routes based off of modifying the interface bandwidth, the cost, or something like that to influence traffic to go one way over another. So that's basic traffic engineering for all of you. So a simple solution is to add a tunnel interface, run routing inside of a GRE tunnel, and then encrypt the GRE tunnel inside of IPsec. Now, the key thing here is where the crypto map applies. So we've already seen the crypto map applies down here at serial 2/1, and then any traffic going out this way towards router 11 or 12, as long as it's going out and matches the extended ACL that we configured in the proxy ACL. As long as that matches, then the traffic will be encrypted. If it doesn't match, it'll be sent clear text. So the crypto map is attached to the physical interface, and this is the physical interface that the tunnel is going to forward traffic over. So it could be the source. The physical interface could be the source of where the traffic is coming from, or it could just be the outgoing interface where the tunnel is traversing traffic through. Either way would work. So a proxy ACL, when you're dealing with GRE though, is GRE encapsulation first, encryption is second, and the proxy ACL is a single entry, which is permit GRE host A, host B. Now what that means is you're going to do, when you're dealing with a GRE tunnel, you're going to be sending traffic to the router. Okay? Now, depending on the type of transport you use, if you use transport mode tunnel, you're routing through the router. If you're using GRE mode, transport mode transport, you're routing to the router. So from router to router. When you're doing tunnel mode, you're going through the router. So it's almost like there's this encrypted gateway from where you're at to where you want to go, and traffic may or may not be directly connected to the router. It might be, several hops behind the router that's actually doing the encryption. But you have your routing set up in such a way that that traffic goes to the router that's doing the actual encryption, and as long as the proxy ACL matches and going out the right direction, you're good to go. So when we configure a interface, so the crypto map is attached at the tunnel interface level, IPsec over GRE, and GRE is transport. The encryption is first and GRE is second. And you have to make sure your proxy ACLs are end-to-end. This is and I don't recommend you do this. I've seen this break networks. So the easy way to do it is the top one here. This is the easy way to do it. Configure a crypto map, apply it to the outgoing interface, so the physical interface, in this case serial 2/1 here. You configure it on serial 2/1, and you make sure you set up the GRE mode as transport. So it's going from router 5 to router 11. Right now it's in tunnel mode, which is the default. So its traffic is actually going through the router to the destination. So that's how that would work. Now when it comes to fragmentation, why would you care? Well, because GRE adds a little bit of overhead, 20 bytes, you need to allow for a little bit of give in your total IP payload, or your MTU. So there's a couple different things you need to pay attention to when you're dealing with this. You have the MTU, the maximum transmittable unit, as well as the maximum segment size. You have the IP MTU configuration command at the interface level, as well as the IP TCP adjust MSS, I think is what it is, underneath the interface. You would adjust these both down to a lower value from 1500 down. And what that's going to allow you to do is going to allow for the overhead of the GRE tunnel, as well as the encryption. Because when you're encrypting it, you're adding additional headers. And actually, I'm going to get into the headers right now, break this down for you. The general idea with the headers is you've got two different modes. Okay, you have the the transport mode, which is a different IP address, which is what we're going to be using. We're actually going to be using transport mode for the way we do it. It's a new IP header, ESP header. And as you can see, I have it broken down into little sections here. I know it's kind of hard to read from the way that I have it set up here, but the general idea is this bracket right here through this bracket right here, all of that is authenticated. So it needs to make sure that the passwords that you set up with your phase 1 and phase 2 work and all that good stuff. And then you go to encrypted. The ESP header, and then when transport mode, you're encrypting from the GRE header all the way back to the ESP trailer. You're also doing that when it comes to the GRE header here. But when you're dealing with tunnel mode, you're actually a little less overhead than it's. And typically speaking, this is where it goes by default. The difference between the two, though, is when you're doing tunnel for your transport mode, you're encrypting both the GRE tunnel as well as the IPsec tunnel. So everything's being encrypted. Okay. The drawback to that is when you're dealing with that's overhead. That's extra headers and extra encapsulation and things like that. What does that mean? Well, that basically what that's taking is that's taking away your maximum capability of forwarding. By default, on Ethernet connections, it's 1500 MTU, right? A 1500 byte MTU. So if you take that and you start adding additional, and that's assuming that you already have a dedicated amount of space allocated for that, which is the 1500. You start adding encapsulation and encryption and headers and stuff like that. That maximum transmission unit, because you're adding everything in, the headers and the encapsulation and the encryption, your overall MTU value starts to decrease. That's why you have to modify the MTU value. But if you don't, if you keep it at 1500, what will end up happening is when router 1 goes to send to router 2, or in this case router 5 goes to send to router 11, router 5 is going to have to fragment in order to forward at the rate that it needs to. Router 11 is going to have to reassemble on his end to make sure he gets everything correctly. Now, typically speaking, when you're dealing with tunnel mode, you're going to be encrypting everything. You're going to be encrypting the tunnel. You're going to be encrypting the data inside of it. So it's going to be, I believe they call it datagram. It's going to be for everything because it's going to be the everything. So it's going to be the payload, the tunnel, the GRE, the IPsec. All that stuff is encrypted. Or if you do transport, all you're encrypting is the actual data in the GRE tunnel. The GRE tunnel itself doesn't get added. So you're actually removing issues. Now, because right here, if you have the GRE IP header, and then you have the original IP header, notice what you're missing out of transport mode. The GRE IP header is a different address, and the original IP header, the GRE IP header. That's less stuff that you have to encapsulate. That's less stuff that you have to encrypt. That's why transport mode is the more specific. Actually, I shouldn't say more specific, but it's better to do it with transport because you're going to have less overhead. So you won't have to modify your MTU and your MSS as much. So the configuration for phase 1 is the same. You would create your phase 1 policy and go about your day, and everything should work out just fine. Now the difference between phase 1, this side, when it comes to GRE over IPsec, is what you're going to be doing is you're going to be setting up the When applied to work with GRE, use the interface used to reach the remote pier of the tunnel. What that means is you're going to be pointing it to the tunnel. Okay, so what you're going to be doing is whatever the destination is, so if that's going to be the remote, let's say you have the loopback address, that's going to be what you're peering to, that's what you're going to be pointing everything towards. So we're going to advertise that into EIGRP, or into OSPF, and that's how we're going to be able to get, BGP. So we're going to be advertising that in so that we can get where we need to go. So since we have a GRE tunnel interface configured, we need to make sure that we allow the GRE across the VPN tunnel. So we need to effectively, we will encrypt GRE with IPsec. So what we need to do is we need to do a create an extended ACL, because we're not matching the traffic that is actually traversing the tunnel. So not the source and destination. We're actually encrypting the traffic that's going to be going over the GRE. So we have to actually change our configuration from the 192.168.100 and 200 ACLs on both sides, where we had the flip-flop that we did in the previous video. Well, here we're not doing that. What we're doing is we're doing a permit GRE any from the from 5 to 11, and that's going to allow us to get the traffic across the setup. And we need to make sure that we set it up for transport mode. That will allow us to get what we need to get going here. So I've got all the configurations set up here. I'm going to walk you guys through how this works, because it is a little convoluted if you've never done it before. So I think it'll be, once we break it down and go through all the steps, I think it'll be a lot easier. So what we're going to do is we're going to blow away the crypto configuration that we have, and we're going to take a look at this, and as we go along, I think it'll make a lot more sense. And the reason why I'm doing it this way is because when we go through it in this particular setup, you'll see the ease to which DMVPN gets deployed. It's much simpler. So what we're going to do is we're going to go to router 5, and click on router 5, and I've actually got to move this over a little bit because my webcam is right in the way. So let's go to global config. We're going to type in IP access list extended. We're going to say GRE. We're going to say permit GRE host, and where we're going to be sending the traffic. So because we have the loopbacks advertised, that's what we're going to use. We're going to use 10.255.11.11, and actually it's 10.255.5.5 to 10.255.11.11, and we have to put host in the front of this one as well. And that's going to be the configuration that we use. We're going to type in do show IP route. Make sure we actually have a route to 255.11.11, which we do. So do ping 10.255.11.11 and sourcing it from our loopback 0. We can ping it. That means we have reachability to it. That's going to be the key thing that we want to pay attention to. So we're actually going to get out of here. We're typing interface tunnel 200. The tunnel source is going to be my loopback 0. The tunnel destination is going to be 10.255.11.11, and the IP address is going to be we're going to say we'll use 200.115.0.5 and a /24 mask. Alright, so that gets us where we need to go. Now what we're going to do is we're going to do the exact same thing on router 11. So we go to global config. We're typing IP access list extended GRE permit GRE host of 10.255.11.11 to host 10.255.5.5, and we're going to exit out of there. Type in interface tunnel 200. Now the tunnel number is arbitrary. It can be whatever you want it to be. The tunnel source is going to be loopback 0. The tunnel destination is going to be 10.255.5.5, and we're going to say the IP address is going to be 200.115.0.11/24. Okay, now what we need to do is we have the GRE tunnel configured. The crypto map is where this comes into play. And the transform set is going to be how we get this associated. Since we already have the configuration, we're going to be calling that phase 1 again, because phase 1 is trying to think here if that would be the smart way to do it. So what I'm going to do is I'm actually going to jump out of here and I'll type in since I have a phase 1 configuration going, so show crypto ISA. Well, it's actually dead now, and the reason why it's dead is because the fact that I haven't sent any traffic over in a while, and the thing is it's got a timeout of 1 day, so 86,400 seconds, and it'll automatically time out. So what I can do now is I can go in here and type in crypto. Let's type in do show run pipe section crypto. Type that in wrong. So let me just type this in crypto. See what we've got going on here. Alright, so I can use this configuration because it's going to be pointing to the right. I could actually blow this away if I wanted to and create a new one. So that's actually what I'm going to do. I'm going to type in crypto ISACAMP policy 1. The encryption is AES. The hash is SHA-256. The authentication is pre-share, and the group is 5. Okay, I'm going to exit out of here. I'm going to type in crypto ISACAMP key. It's going to be CCNP question mark, and then the address, and I'm going to use the remote address. Okay, so I'm going to type in 10.255.5.5 question mark, and I'm going to hit, and you can put a default subnet mask in if you want to, do a /32 if you wanted to, but I'm not going to do that here. Next thing I'm going to do is I have to go in here and type in crypto map name, or crypto map, and then the name of it is going to be GRE _ IPsec. Okay, that's so that we know what we're doing with it. It's going to be the number is going to be 1, and then we're going to say it's going to be an IPsec ISACAMP tunnel, and we're going to say hit enter. And now, if I believe, don't quote me on this one, but I'm pretty sure if you were to use dynamic, this is where you would use remote access VPNs. Okay, so if you have teleworkers or people from home that want a VPN in, this is how you would set that up. And now it says it's going to be disabled until a pure and a valid access list have been configured. So what I need to type in now is I need to type in a match address, and the ACL's name is going to be GRE, and hit enter. So it's going to know what to send the traffic to. We're going to set the peer to be 10.255.5.5, and then set the transform set. Since I already have one configured, I'm not going to mess with it. Since I already have a transform set of R5 to R11, that will work just fine. But now see, set transform set to that. Now what I actually have to do now is that the transform set that I have configured here, I actually have to modify this. Now with the point of doing the transform set this way, and we have to set this up, and doing this, we have to type in mode, and the encapsulation for is going to be transport. And the reason we have to do this is because of the fact that we're setting it up so it's going to be router to router configuration instead of going through. So it says datagram encapsulation. This is going to be allowing like opening up a tunnel through the router to allow the traffic through, instead of encrypting the traffic over the GRE in order for the routers to talk to each other. So we're going to use that. We're going to exit out of here, and then what I'm going to do now is I'm going to type in what we have to make sure we do is the new encapsulation, because the tunnel is different now because we've named it differently. So if I type in do show run interface serial 2/0, the crypto map is IPsec, so it's not going to work. So interface serial 2/0, pull that crypto map off. What that crypto map is now, ISACAMP will fail because it's going to get turned off now. Now we have to type in crypto map, and the crypto map's name is GRE IPsec. Okay, we do that, question mark, and hit enter, and we're good to go. Now IPsec will get turned back on. And we type in do show run pipe section crypto. Now I'm going to take all that configuration, open up Notepad, copy and paste it in, and then we're going to tweak what we have to tweak. So here we go. Now let me make sure I grab all this right here. Now we have now imagine if you had several tunnels. You'd have to have a separate phase 1, or the phase 1 policy you could do the same across the board, but you could use the same encryption capabilities across the board. That is a possibility. That is a capability. The drawback to it is if you're doing GRE over IPsec, you'd have to have a different set peer. So you'd have to continually reapply this stuff. So unless you were to use, and I don't believe you can use just an all zeros peer. I believe you have to use a. So we're going to use this one right here. We're going to pull this phase 1 here, or sorry, this one right here needs to get pulled out. And pull this guy out, and then pull this guy out. And then we're going to do, this guy is going to get pulled out. So this is our configuration. And if I do a quick do show, I've already actually configured the access list, so I don't have to worry about that. But the point being here is you need to make sure you have the right configuration in the right places for this stuff to grab. So what we're going to do is we're going to type in 11.11 here and 11.11 here. We're going to grab this information right here, and we're going to go over, we're going to paste that into router 5. So we're going to right click and paste this in. So that gets us there. Now we're going to go to interface serial 2/1, do show run interface serial 2/1. We're going to type in no crypto map IPsec. Type in crypto map, and the name of it is GRE IPsec. Hit enter. That's going to turn IPsec back on. And then when we do this, any traffic that goes across this should get automatically encrypted. So we type in do show crypto ISASA. Alright, we don't have anything going across yet, right? But what I need to do, because I haven't added let's do a show IP interface brief pipe exclude UNA. I haven't actually advertised this this connection into OSPF yet. So that's what I'm going to need to do now. So interface tunnel 200, type in IP OSPF 5 is going to be OSP or area 100. Okay, that'll turn it on there. Now if I go to router 11, I type in interface serial 2/1. I'm sorry, interface tunnel 200, and type in IP OSPF 11 area 100. I should form an adjacency over that. Do show IP or IP protocol summary. Okay, I got the right OSPF adjacent set up there. Let's see here. Show IP OSPF interface brief. Notice the cost is 1,000. It's a point-to-point out of the gate. Now let's ping the other end of this link, 200.115.0.5. Okay, there's our problem. Show run interface tunnel 200. Let's see here. Okay, I think I'm missing a little bit of config here. Let's jump up to config T, type in what is that? Crypto map, and we have GRE underscore IPsec question mark, and the local address needs to be loopback 0. See if that makes any difference to it. Do the same thing on router 5. Actually, let's just grab this right here because it's going to be the same on both ends. Grab this on router 5 and hit that. Now, because we have reachability to the other side, so ping.255.11.11, sourcing it off of 10.255.5.5, we have reachability to it. Oh, there goes the tunnel. Okay, so I was right on my configuration. I needed to point it to the loopback so it knew where to source off of. So we have that peering up now, right? Let's go down to router 11 and jump down out here and do a show IP route. Now you'll see some things are going to be coming across tunnel 200, some are not. So if we wanted to do a trace route to the 100 network, so do a trace to 100.100.100.100, we jump right across to 5, and notice the other end of the address is this guy. Now we are encrypting it, that's why the trace routes are so slow, because it's being encrypted as we go across. So that's a GRE tunnel, going over a GRE over IPsec. So let me do a quick recap of the config, because I think that'll help dial everything back in. So I'm going to do a show run pipe section crypto access, and let's see here, interface tunnel 200. Let's see if that'll pull. And I believe it did. So basically what we have here, we have our phase, policy 1 is our config. So let me pull the applicable configuration out here. And let me grab this stuff right here. I'll grab it all and then I will plop it in here and filter out what doesn't need to be in here. So it makes it easier for you guys to read. So we have this guy right here is gone. Let's see. Let's pull that out. Alright, so this is the configuration for router 5. So we have our phase 1 policy here. Phase 1 policy states that we're going, this is for router to router configuration. And we have our setup here going with our 4 attributes: the encryption, the hashing, the authentication, and then our grouping, or the group. And like I said, I'm not going into a lot of detail on how the actual IPsec part works. More or less, just so you guys can see what the config looks like. I go into a lot more detail on the CCIE videos, so do definitely check that out. So let me bring this back in real quick. So basically, what we have here, and we have this is a pre-shared key. So the pre-shared key is going to allow both ends to talk. The pre-shared key has to match. Now, what if you don't want to use a pre-shared key? What if you want to use some other capability? Well, what else is there out there to use? Well, you could use PKI, which PKI is going to be public key encryption. Public key infrastructure, I believe is what it stands for. And basically, you're going to be using a certificate to authenticate with. That's the general idea for it. I've never actually used that. It's always been pre-shared key. It's the easiest way to go with it. But depending on your environment and depending on like your compliance needs for if you're dealing with Starbucks or PCI, you might have to go with those two. But as we go along, we have the transport set up, and we have to have transport mode enabled in order for GRE over IPsec to work. So we're only encrypting the actual traffic inside the tunnel. We're not encrypting the GRE itself. So we go down here, we have the GRE over IPsec. We're telling it what the loopback is. So we're telling the configuration, look for the loopback. And if we didn't use that, we'd have to point it to something else. And then we have their the name of the crypto map. It's policy 1, so it's the highest priority there is. IPsec ISACamp. And then we're coming down here and we have our phase 2 configuration, calling the transform set R5, R11, which is right here. Mode of transport. Then we come down a little farther, we're matched address GRE. We have the GRE extended ACL, which is going from 5 to 11 and vice versa on the other side, going from there. And there's a question, what about our show crypto? show crypto ISA, it's active. It's absolutely active. And then if we go take a look at that, that's set up. And if we do a show crypto sessions, we should have 3 separate going on. And the first one here is going to be our GRE over IPsec one. And the 2 below that are going to be the these guys are actually, no, I take this back. This is just one. 255. I'm honestly not sure where these are coming up because the config is still in there. So actually, both tunnels are up. So our configuration for both the static IPsec VPN as well as our GRE over IPsec, they're both working again. But in order for this to work, you need to make sure you have configuration going across the wire. So because of the fact we have GRE over IPsec now, it should stay up continuously, and we should be able to go from there. So that gives you the idea of how that would work. So the next video we're going to do, which I think you guys are going to enjoy because of the fact that we're going to be taking this and we're going to simplify the configuration, is we're going to do DMVPN. And DMVPN adds a level of complexity. There's more to understand, but it's actually easier to scale. Because the one thing about here is, for every connection you want to have to a remote spoke. So let's say, for instance, let me minimize this real quick. Let's say you have the 2 spokes, right? And you have your hub going down to 2 spokes. In order for you to have 2 connections going on, you need to have 2 separate tunnels. So tunnel, a tunnel going from router 5 to 11, and a tunnel going from router 5 down to router 12. Because remember, with GRE, it's a static point-to-point tunnel. There's nothing dynamic or multi-point about it. We haven't gone that route yet. So in order for you to be able to scale, we'll say you've last big environment I should say that I worked inside of had 300 spokes, and they were all mostly connected via MPLS VPN. The network manager, and I was a consultant working on site at this project. The network manager came to me and said, we want to do a solution for a backup secure internet connection in case our MPLS VPN goes down. All sites had a backup internet connection. I said, okay, DMVPN. You don't have to encrypt it because you guys are UK based or European based. And he goes, how long do you think that would take you to get in place? It's not long at all. As long as you have reachability from here to there via public IP, you're good to go. It would take me an hour maybe to get a dozen sites going. I see, because once you configure the hub and you get the hub in place, and then you configure the spokes, it's actually pretty much copy paste. And he goes, really? I said, yeah, it's very, very simple. And I said, because you have such a large network, I would do a /23 to have everybody on the same subnet. And he goes, I like the sounds of that. So it took we did a few sites in the core. So like for instance, we did a Wisconsin site, and like a Chicago, and like say New York, just to test it inside the U.S. And then we did one in the EMEA region in the U.K. just to show that we could go across the Atlantic to get connectivity. Everything worked great. And so we had to have one tunnel. One. The benefit? One tunnel. A lot less overhead. So, in the next video, I'm going to give you guys a high-level overview of DMVPN, and then we're going to start working our way down into the nooks and crannies, and it's literally very, very simple to get going. And I will show you a different way to get the configuration going with the crypto once we finish that video out. So, I hope this has been informative for you, and I'd like to thank you for viewing.